So we're going to move off into congruence. What does it mean for two shapes to be congruent? Essentially what congruence means is that shapes are the exact same size, obviously the same shape, the same angle measures, they have the same side length. So one will fit exactly over the other. So imagine you have two squares that are the same shape, they're congruent, they'd be the exact same. You can stack one on top of the other, and from a bird's eye view looking down, it might look like it's just one square because they are the exact same. So we're going to talk about congruence in terms of transformations. How can we prove that two shapes are actually congruent? We can prove that two shapes are congruent by performing a sequence of transformations to place one shape directly over the other. So what is a sequence of transformations? That's essentially more than one transformation. So we learned about translations, reflections, rotations, all individually, but now we have to use multiple, more than one transformation to describe how to place one shape on top of the other, which essentially proves that they are congruent. So, for example, I want to place shape ABCD directly on top of A prime, B prime, C prime, D prime to prove that these two shapes are indeed congruent. How do I do that? I need to be able to explain a sequence of transformations to place one directly on top of the other. So let's go ahead and take a look at this. Shape ABCD. We can see that these are our prime points down here. So this is the original shape and this is obviously the new shape. Wherever you see prime points, that is your newer shape. So we need to move this shape ABCD somehow here to prove that the two are congruent. How do we do that? First and foremost, we must be able to understand that we're going to have to rotate. And at least one of our transformations has to be a rotation, because our original shape, the point A is facing toward the north. Point A on our new shape is pointing toward the west. So we know that we're going to have to rotate. Which way are we rotating? Think about the way a hands of a clock move. Usually the hands of a clock move this way. And counter to that, the opposite of a clock would move this way. So here's opposite of a clock. Here's how a clock moves. So this would be clockwise, and this would be counterclockwise. So we know this shape is going to need to be rotated counterclockwise. So let's go ahead and talk about how many degrees you might need to rotate. It looks like if we can go from this quadrant and rotate it over to this quadrant, our shapes will be facing the same direction. So point A would need to now be facing this way to begin our sequence here. So how many degrees is a rotation that makes point A face towards the west versus the north? That's going to be a 90-degree rotation. And we always have to have a center of rotation. And in this case, we can use our origin. We need to use our origin 0, 0 to go ahead and rotate this shape 90 degrees counterclockwise, so that we can prove that it is indeed congruent to this shape. So, how do I rotate this shape 90 degrees counterclockwise? We learned in our video about rotations that to rotate 90 counterclockwise, you need to take your original points and first switch them around and make your A value become opposite. So, for example, point A, I have 3, 5. I know I'm going to have to switch those values. What do I switch those values to? 5, 3. And the original X value becomes opposite. So 3 was originally our X value. I switched it to. Now I have 5, -3. 5, -3. So I want to go ahead and place a point at 5, -3. Oh, we're going counterclockwise. Sorry. So we need to go switch the 2 and the Y becomes opposite. So we switch, and so we should have -5, +3. Since our Y value becomes opposite, 5 was originally Y. We switch, we have -5, 3. Let's place a point at -5, 3. negative 5 comma 3. And then we will move on to point B here. We are at 4 comma 2. Again, we're going counterclockwise. Switch to 2. Y becomes opposite. We should have negative 2 comma 4. So I go to negative 2 comma 4. Let's keep it moving. We will have C next, which is at 3 comma 1. Switch to 2. We'll have 1 comma 3, but our Y value becomes opposite. We would have negative 1 comma 3. Negative 1 comma 3. Negative 1 comma 3. Here is negative 1, 3. Then we should have our point D, which is at 2 comma 2. Switch to 2. Y becomes opposite. Negative 2 comma 2. Negative 2 comma 2. And that is a 90-degree rotation counterclockwise. That is a 90-degree rotation counterclockwise. And now what I need to do is perform another transformation. So I performed one transformation, which was a rotation of 90-degree clockwise. Sequences of transformations require more than one. I only did one here, which I rotated ABCD 90-degree counterclockwise. Now what do I need to do? This was point A here. This was point B here. I'm sorry, this was point, yes, B. This was point C, and this was point D. How do I match up my point A with my point A prime? How many units do I need to translate down? And there's one or two ways you could think about this. You could think of point A being at negative 5 comma 3. You can think of point A now being at negative 5 comma 3. How many units do I need to translate down? If we're translating down, we're talking about our y-axis. If we're translating down, and this should be positive 3, I apologize. Positive 3. If we are translating down, how many units do we need to translate down, which is y-axis, to make our positive 3 turn into a negative 3? How many units from positive 3 to 0? That's 3 units. How many units from 0 to negative 3? That is a total of 6 units. I need to translate down 6 units. And if I do that, my shape ABCD, my original shape, will be now placed directly on top of A prime, B prime, C prime, D prime. Let's go ahead and count that out. I translate down 1, 2, 3, 4, 5, 6. I translate point B down 1, 2, 3, 4, 5, 6. D or C 1, 2, 3, 4, 5, 6. D 1, 2, 3, 4, 5, 6. So that would be us successfully performing a sequence of transformations to place our original figure ABCD directly on top of A prime, B prime, C prime, D prime. And let's go ahead and write that sequence out. So we originally rotated ABCD. What is our sequence? Rotate figure A, B, C, D 90 degrees CCW, which is counterclockwise, and translate each point down 6 units. 6 units. That is us successfully performing a sequence of transformations that takes shape ABCD and places it directly on top of A prime, C prime, A prime, B prime, C prime, D prime.